Well, hello and welcome to a little overview on linear equation writing. You'll find this helps you with at least 2 or 3 of the online assignments. And let's get ourselves going here. The topics we'll be covering in this video will be how to write the equation for a line if we are given 2 points, or if we are given a point and a slope, or perhaps if we're given the intercepts. I'll make a few reminders about how we can use the slope and the intercepts to check to make sure that we've done a nice job writing our equation for our line, and also we'll have a small chat about special cases as we go along. So without further ado, let's get started here. Now the first thing we'll consider will be an example of being given 2 points and how we might write the equation for the line. Now there are a couple of forms for lines, and again there'll be other videos on each specific form, but in our case here we'll start with y equals mx plus b form. So if we have y is equal to mx plus b, then what we'll need to determine from our 2 points here are the slope and the intercept. Now the slope we'll get by doing a rise over run, so the change in the y compared to the change in the x. So just a reminder that m is equal to the change in y, and this is compared to the change in x. And we need to go from one point to the other each time correctly. So if we think of this as maybe point 1 here and this is point 2, and we take the difference from the y coordinates in number 1, we'll take away the y coordinate in number 2, and then for x we'll do the same thing. We'll take away the x coordinate in number 2 away from the x coordinate in number 1. And let's see, this gives us a positive 8 in the numerator, and then this gives us a negative 2 in the denominator. So it looks like we actually have a negative slope here, and the negative slope is 4. So we can go back to our equation. We can start with that, and we know that y is therefore equal to negative 4x plus some constant here, and this constant is going to be the y-intercept. We can take either of our 2 points and we can substitute in for x and y and then solve for the unknown b, and we should be done with our equation. Now let's take 3 and 4 because that's simpler than negative 4 and 5. So x is equal to 3, so that's negative 4 times 3. I have the unknown b here, and then y is equal to 4, so that's 4 equal to negative 12. And in order to solve that, we'll have negative 12, 4 equal to negative 12 plus b. We add 12 to both sides, and we have finally that b is equal to 16. A little therefore symbol. Now, given that we have the slope, which is negative 4, and we have the intercept, which is 16, we should be ready to now combine these all into our final equation, which I'll leave here in red, which is y is equal to negative 4x plus 16. Now this would be using the y equals mx plus b form, which is not a bad way to start. Let me also take a look quickly at how we would do this by point-slope form, for those of you feeling more confident with this sort of thing. So if we had point-slope form, all we would need to do is find the slope, which we did back here, this negative 4, and then use either point 3, 4, or 5, negative 4. And this is the form for point-slope. So we would have y minus one of the particular y coordinates, and let's pick the easy one, which is 4. And then we simply use the slope, and we plug in x minus 3. And I will leave it for you to test to make sure these two things are the same. If you distribute the negative 4 and then add the 4 across, you should get the exact same equation here. In that other equation, and we'll put this as an OR, y minus y 0 or y naught is equal to m times x minus x naught. This second form, the point-slope form, is the preferred method for going rapidly to a solution that you don't need to know much about in terms of intercepts and so forth. So it's a very handy one, but maybe not as clean as using the slope-intercept form. So you get used to using both and see if you can't pick your own two set of points and see if you come up with the equations in two different ways, and then make sure that they are the same. And now we'll move on to another example. Now in our second example, we're given a much easier setup to work with. For some reason, someone did all the work of finding the slope, and we have the point 2,5. So let's remind ourselves we have one option, which is going to be the mx plus b form. Not a bad form to use if you're given the right things. Now I don't see that I was given the intercept, but I do have a slope and I do have a point, so I think I might prefer to use my point slope form. Oh, let's back that up just a little bit. The point slope form, and then if I need to, I'll convert that into the slope intercept form. So this is the form that I'm going to prefer to use when I'm kind of in a hurry just to get an equation, but not really needing it in a kind of a clean form. So the y-coordinate in question is 5. Oh, I keep doing that equal sign there. Back that up. Y minus the y-coordinate, which is 5, and that's equal to the slope, -4, times x minus 2, which is the given x-coordinate. Now if we wish to, we can take this form and pretty quickly turn this into mx plus b form. And this is really usually how I go about doing it. So I can take the -4 and distribute that on. So that's -4x. And we'll distribute the -4 onto the -2. That's a +8. And I have the -5 still sitting there. Now I'll add 5 to both sides. And I now have y equals -4x plus 5 is going to give me 13. And there's my intercept now. So there's that y equals mx plus b form that many of us are used to, but found using the point slope form. Now if we wish to, we could have used the slope intercept form, or sorry, the slope intercept form, and we could have done kind of the hard work of it. We could have taken the slope, which is -4, and we could have put this in, and it's equal to x. Now x is 2 in our problem. We have the unknown b. We can put y equals 5 in, -8. 5 is equal to -8 plus b. We can add 8 across, that's 13 is b. Then we go back to our equation and we can write in finally y equals -4x plus 13, and lo and behold they are the same, which is just what they ought to be. Alright, next example.